Hello everyone and welcome back to the Backend Masterclass. In the previous lecture, we've learned how to build a minimal Docker image for our Golang application. The image we built was pretty small, just 17.7 megabytes. However, I'm not sure it's gonna work well or not because we haven't tried to run it yet. So let's do that now. To start a container from this image, we will use a docker run command. The name option is used to specify the name of the container we're going to create. Let's say Simple Bank. Then the P option is used to publish the port 8080 to the external host machine. Finally, the last argument we must provide is the name and tag of the image, which is Simple Bank latest. Oops, we've got an error. Cannot load config. Config file app not found. This is what I expected. Do you remember that we used Viper to load the app.env config file in the lecture 12? But this file doesn't exist in the Docker image that we built. In the last lecture, we just copied the binary executable file, but we didn't copy this config file to the final run stage image. So to fix the error, we have to copy the app.env file to that image as well. Now I know this is just a config file we use for development, which connects to the local PostgreSDB and uses a trivial token symmetric key. So it should not be used in the production image, right? Don't worry, we will learn how to replace this file with the real production config file in another lecture, when we update our CI/CD workflow to automatically build the image for us. For now, let's just use this development config to test our Docker image first. Alright, since the last docker run command failed, if we run docker ps-a, we can see that it left behind an existed SimpleBank container. So let's run docker rm SimpleBank to remove this container. Now before we rebuild the Docker image, let's run docker rmi to remove the old SimpleBank image. Then let's run docker build command to rebuild it. Okay, now we have the new image. Let's run it. This time the error is gone. The server has started successfully. Here you can see a warning that Gin is running in debug mode. In production, we can set this Gin mode environment variable to release to instruct Gin that it would run the server in release mode instead. So let's stop the server and try it. I'm going to remove the old SimpleBank container and start a new one with the same docker run command. But this time we will use the -e option to set the Gin mode environment variable to release. And voila, the server has started. But now we don't see any debug logs as before, so it worked. If we open another terminal tab and run docker ps, we can see that the SimpleBank container is up and running, together with the PostgreSQL database container. Okay, now let's open Postman and send a request to make sure that it is working properly. I'm going to call this login user API. Oops, we've got a 500 internal server error. And the reason is the server cannot connect to localhost port 5432, which is the address of our Postgres database. In the terminal, we can see the log of this request here. So what happened? We've already confirmed that the PostgreSDB container is also running, right? Yes, but the problem is that, as stated in the app.env file, we're connecting to the database via the localhost address. But the SimpleBank and Postgres containers are two separate containers. So actually they don't have the same network IP address. We can run this docker container inspect command to see the network settings of the PostgreSQL container. As you can see here, it's running on the default bridge network. And its IP address is 172.17.0.3. Now let's run docker container inspect SimpleBank. Voila, the IP address of the SimpleBank container is different, 172.17.0.2, although it's running on the same default bridge network with the Postgres container. So now you know why we cannot use a localhost to connect to Postgres container. But how can we fix it? Well, the easiest way is to just replace localhost with the real IP address of the PostgreSQL container in the app.env config file, like this, and rebuild the Docker image. However, it's not very convenient because we will have to rebuild the image every time the IP address of the Postgres container changes. In fact, there's a better way to change the DB source without rebuilding the image. Keep in mind that we are using Viper to read the config, and it has the ability to override the config written in the app.env file with the value we provide via environment variables. So I'm going to stop the current Simplebank container, remove it, and start a new Simplebank container. But this time, I will add one more environment variable to override the DB source value with the real IP of the Postgres container. Oh, we have an error because this DB source URL contains several special characters. So we should wrap it inside a pair of double quotes. Just like that. And voila, the server is now started successfully. Now let's send the login request again to see how it goes. Yay, it's successful. We've got a new access token. So now you know how to connect your container to another standalone container via its IP address. IP address can change if we restart the container, so using it is not really ideal. Let's stop the Simplebank container and remove it. Then I'm going to show you a better way to connect to Postgres without using IP address, but using user-defined network instead. Now if we run docker network ls, we can see the default bridge network that our Simplebank and Postgres containers were using. We can see more details about this network by running docker network inspect and passing the network name bridge. Here in the containers block, we can see the list of containers that are running on this network. Right now, only Postgres 12 container is using it because we've just removed the Simplebank container. Normally, containers running on the same network can discover each other via name instead of IP address. However, it doesn't work for the default bridge network. So what we need to do is to create our own network and put both Postgres container and Simplebank container on this network. Then they will be able to call each other using names. Docker provides several commands to manage networks. Let's use the docker network create command to create a new network. I'm going to call it bank network. Then we can use the docker network connect command to connect the existing Postgres container to it. Here's the syntax. So docker network connect, then the name of the network, bank network, and finally the name of the container, Postgres 12. Now if we run docker network inspect bank network, we can see that the Postgres 12 container has been connected to this network. And if we inspect the Postgres 12 container, we can see that it is now connected to two different networks. The bank network that we've just created and the default bridge network that it was originally connected to. It's totally okay for a container to be connected to multiple networks at the same time. Alright, now it's time to recreate the Simplebank container that will connect to this new network. We will use the same docker run command as before, but we will add one more option, network, and pass in the name of the network, bank network. This time the Simplebank container will be running on the same network with Postgres, so it can discover the Postgres container's address by its name. So let's replace this IP address with Postgres 12. And that's it. The server is now started. Let's resend the login request to see if it's working or not. Yay, the request is successful. Awesome. So the Simplebank container has successfully talked to the Postgres container using its name instead of IP address. That's pretty cool, isn't it? Now, if we inspect the bank network, we can see that there are two containers connecting to it, Simplebank and Postgres 12. So now you know how to take advantages of the user-defined network to allow two standalone containers to talk to each other by names. Before we finish, I'm going to update the make Postgres command to connect itself to the bank network upon creation. Then let's add all the changes we made so far, create a commit, and push it to GitHub. Okay, here we can see the new commit in this pull request. When you work on a team, your teammate can go to this PR to review your code. You can click on any line to write a comment like this, and click add single comment or start a review. You can also select multiple lines to leave a comment that involves all of them. And once the code is properly reviewed and unit test passed, we can merge it to the base branch, which is master in this case. Let's click merge pull request, confirm merge, and finally delete the feature branch. And that's it, we're done. The pull request is successfully merged to master. And that wraps up today's lecture about Docker networking. I hope you find it useful. Thanks a lot for watching. Happy learning and see you in the next lecture.